Hello, today I'm going to show you this integral. It's from the MIT Integration Bee, the qualifying round in 2019, and it's question 13 from that. So the integral itself is we're going from 0 to e, and we're integrating x to the power of 1 over the natural log of x, all with respect to x. So the first step we're going to do is we're going to use the substitution, and we're going to let u equal the natural log of x. So straight away, we know that e to the u is equal to x. And we can work out how to replace our dx by differentiating both sides with respect to u. And that gives us then that dx du is equal to e to the u. So our dx, we replace it with e to the u multiplied by du. Beautiful. The next step to look at then is going to be our limits of integration. And the top limit is kind of easy to do, because if we plug e into here, the natural log of e is just 1. So u, when evaluated at x is equal to e, it's going to be equal to 1. But the value for 0 isn't defined. But we know that it tends towards negative infinity. So what we're going to do is we'll say that u, when evaluated at x equals 0, is equal to some number a. And we know that a tends towards negative infinity. Beautiful. So let's rewrite our integral in terms of u. We're going to be able to write it like this then. So it's going to go from a to 1. And x, we replace with e to the u. And that's raised to the power of then 1 over natural log of u. And the natural log of x, And the natural log of x is equal to u. So that's 1 over u. And all now has been integrated. Our dx gets replaced with eu du. Beautiful. I've left this little gap at the front because we need to take this to the limit as a tends to negative infinity, because that's what we had over here. So next step then is to look at this little bit, the first bit basically, and think when we have something raised to the power of something else, but there's a power inside it, we can effectively just multiply those two powers together. So what we're going to be left with in that section is just e to the 1, because u divided by u is just 1. And that will get times by e to the u, and we'll put in our integration, a to the 1, and the limit as a tends to minus infinity, and du is still there. Beautiful. Our next step then is we can basically take out this value of e and put it out the front. So we'll do that. So it's going to be the limit a tends to minus infinity, the integral from a to 1 multiplied by e of e to the u with respect to du. We can do that because e is just a constant. It's just a value, like 2.7 something. So we can take it out the front. You can do it with any constant. Next step then, we're going to actually do our integration. And what we get then is the limit as a tends to negative infinity of e multiplied by e to the u, because when we integrate e to the u, we just get e to the u again. And that's going to be evaluated at 1 and a. Beautiful. Next step then, we'll keep going. The limit as a tends to negative infinity of e multiplied by, now when we put in the limits of these things, we're going to get, well, just e for the first one, take away e to the a, all like that. Next step, we'll expand this bracket. We get the limit as a tends to negative infinity of e squared minus e times ea. I could have written this up here as e to the power of a plus 1, but we'll leave it like this for a minute. Next step then, we know the limit of a sum is the sum of the limits, and the limit of a takeaway is the takeaway of limits. So we'll write this as two different limits. We have the limit as a tends to negative infinity of e squared minus the limit as a tends to minus infinity of e times e to the a. And again, we can take this constant out the front, and we'll do that now. So what we can see now is this first part, the first term that we have here, there's no a's involved. So the limit is already solved. So it's just going to be e squared. And looking at the second part, the value of e to the a as a tends to minus infinity, well, if we think about the curve e to the a, goes up like this, and as we go to negative infinity, it goes down to 0. So the limit of that is 0. So this is going to be e minus 0, which is just 0. So all in the end, we end up with e squared, and that's the final answer.